Good morning, students. Today I am going to discuss about very important aspects to remove your confusion. And first is sometime whenever you will find out the oxidation state by normal methods by following general rules, in that case the oxidation state is found to be unexpected. Like in case of H2SO5, if I would like to find out the oxidation state by normal method, in that case the oxidation state comes out to be plus 8. 2 into plus 1 plus x plus 5 into minus 2. So the oxidation state of oxygen is generally taken as minus 2. It comes out to plus 8, which is wrong. Which is not possible because the configuration of sulfur is 2, 8 and 6. So the minimum oxidation state is minus 2 and highest plus 6. You cannot remove more than 6 electrons. So I have to count for the fallacy what mistake I have committed to find out the oxidation state. In that case, we have to see the structure. We have to see the formula. Now in this case, I found there are two oxygen which are having peroxide linkage, O single bond O. This type of linkage, it may be hydrogen peroxide, it may be sodium peroxide, or this is peroxosulfuric acid. Sulfuric acid is H2SO4 and this is H2SO5. Here is peroxide linkage. And in case of peroxide, the rule is the oxidation state of oxygen is taken as minus 1. So the oxidation state of sulfur is, I will assume it is X. There are 3 oxygen which exist in the form of oxide, 3 into minus 2. But there are 2 oxygen which are in the form of peroxide. In case of peroxide, the oxidation state is taken as minus 1. And there are 2 hydrogen and they are attached with non-metal. So the oxidation state of hydrogen is taken as plus 1. There are 2 hydrogen, 2 into plus 1. And hence we get the oxidation state plus 6. Now it is correct. So I counted for the fallacy. I found what mistake I have committed in the journal by following the journal method. Similarly, in case of CR5, very important from application point of view. The generally asked the oxidation state of chromium is option plus 4 plus 6 plus 8 plus 10. Generally student write it as plus 10, but it is wrong. The reason, the chromium has atomic number 24. The configuration 2814 is wrong because outer motion cannot have more than 8 electrons. So I corrected it to 8, 8 and 6. So the maximum you can remove 6 electrons. Or the electron configuration argon 3d5 for s1. You can remove only 5 and 1, 6 electrons. Plus 10 oxidation state is not possible even for a single element present in the periodic table. The maximum oxidation state is plus 8, not more than this one. But in that case, we have to see the configuration also. At least we can remove the 8 electron to attain the noble gas configuration. But in this case, it is not possible. So what mistake I have committed? These 4 oxygen are peroxide oxygens. Only this is oxide. So x plus 4 into minus 1 plus minus 2 equal to 0. For this is minus 2. This is corresponding to peroxide and this is for oxide. Now it is correct, comes out to plus 6. Similarly in this case, the oxidation state comes out to plus 7, but the highest possible is plus 6. The reason is there are 2 oxygen which have peroxide linkage. So there are 2 sulfur 2x 6 oxygen, 1 2 3 4 5 6 corresponding oxide, and 2 oxygen corresponding to peroxide, and 2 hydrogen plus 1. Now it comes out with plus 6. So in this way we can find out the mistake that and in question is used to use the term count for the fallacy in these compounds. Now next important topic is sometimes we blindly say this compound acts as only oxidant and this one acts as a reductant and this acts as a both oxidant and reductant both. And sometimes we use that this also participate in disproportionation reaction. What do you know disproportionate reaction? Self oxidation reduction. अपना ही ऑक्सीडेशन अपना ही रिडक्शन पर हो जाता है, खुद ही ऑक्सीडाइजिंग खुद ही रिड्यूसिंग एजेंट का काम करे रिएक्शन में, उसे हम क्या उस रिएक्शन को क्या बोलते हैं? डिसप्रोपोर्शनेट रिएक्शन. तो हम बहुत सारे ऐसे एग्जाम्पल लेते हैं कि जिसके अंदर उसका खुद का ही ऑक्सीडेशन होगा, खुद का रिडक्शन होगा. बाद में का एक हाइड्रोजन पेरोक्साइड में हमने देखा ही है, चैप्टर कर लिया हमने. हाइड्रोजन पेरोक्साइड से बहुत ऑक्सीडाइजिंग एजेंट भी रिड्यूसिंग एजेंट भी कॉम्पिटिटिव रिएक्शन हो रहा है. तो किस बेस पर डिसाइड कर लेते हैं हम कौन ओनली ऑक्सीडेंट कौन ओनली रिडक्टेंट, कौन दोनों का पार्टिसिपेट करेगा? If the oxidation, in case of lowest oxidation state, then it acts as a only reductant. In highest oxidation state, only oxidant. Means you cannot oxidize it further. अगर उसको ऑक्सीडाइज करेंगे फिर तो रिड्यूसिंग एजेंट हो सकता है. You cannot oxidize. It is already in highest oxidation state. And if oxidation state lies in between lowest and highest value, then acts as a both oxidant and reductant. And if acts as both of it, it will participate in disproportionate reactions also. Like in case of nitrogen, the configuration is 2 and 5. So the lowest possible oxidation state is -3 and highest is +5. You can remove maximum 5 electrons. So let us see. In case of ammonia, the oxidation state of nitrogen comes out to be -3. X plus 3 equal to 0, X is equal to -3. And this is the lowest oxidation state. It means ammonia acts as only reductant. It will never act as an oxidant. NO2 plus 4, X minus 4 equal to 0, X is equal to plus 4. It will participate in both oxidant and reductant. It acts as an oxidant and reductant both. It will participate in disproportionate reaction. That depends on another component. And if it is alone, then it will participate in both. Similarly, NO will also participate in both oxidation reduction and disproportionate reaction. But in case of HNO3, the oxidation state of nitrogen comes out to +5, which is highest. So it acts as an only oxidant. In 10th class, in 11th class, we studied various reactions that is an oxidant only. Why? Now we can, I can put up with this question, why nitric acid is an only oxidant? You will say the oxidation state of nitrogen is +5, and which is highest possible oxidation state for nitrogen, hence acts as only oxidant. H2S, upon 286, the lowest is -2, highest is +6, and this is lowest, so it's only reductant. SO2 plus 4, oxidant and reductant both. But in case of H2SO4, the oxidation state comes out +6, means only oxidant. MnO4, the oxidation state comes out to be +7. So the valence shell contains, the outer confidence 3 5 4 is 2. The outermost shell contains 7 atoms. Means you can remove 7 atoms. the highest possible oxidation state for magnesium, because 25 it is 2, 8, 8 and 7. 10 plus 15, 25. So you can remove maximum 7 electrons. So this is highest possible oxidation. So MnO4 negative, it may be KMnO4. That's as an only oxidant. In case of chlorine, the lowest is -1, 2 at 7. Lowest is -1, highest is +7. So the +5 lies in between -1 and +7. So acts as an oxidant or reductant. Hydrogen peroxide, -2 to +2. So oxidation state in between them, hence acts as both oxidant and reductant, that we discussed in the chapter hydrogen. In the properties of hydrogen peroxide has both oxidant and reductant both. In this way, we can decide which will act as an oxidant, which one acts as a reductant, which one acts as both oxidant and reductant. Now, another important question is, if the oxidation state is in fraction, then what conclusion you draw? We found in various cases the oxidation state comes out in a fraction. What does it mean? The meaning is that compound, that substance contains 2 or more atoms of same element having different oxidation state. All the atoms of same element don't have same oxidation state. They have different oxidation state. And that average value is in fraction. Like in C3O2, 3x plus 2 into 1 comes plus 4 by 3, which is in fraction. Why? More than 1 atoms of same elements are present. The structure is this one. The definition is, the oxidation state of an atom of element is apparent charge or residual charge present when all other atoms of another element are moved in the form of ion. So in this case, you will remove oxygen in the form of O2 negative. So in this case, you will get +2. In this case, you will also remove oxygen. But in this case, this is another element. This is the same element. The definition, when all other elements are moved. When all other atoms nahi hai, when all other elements are moved. So on this side is also carbon element, on this also carbon element. They are same element. They will not be removed, and hence they are not moved, and then the oxidation state is 0. So the +4 oxidation state is distributed over 3 carbon, and hence the average value comes out to +4 by 3. Similarly, in this case, H2S4 of 6, 2 into +1 plus 4x plus 6 into -2, then x comes to +5 by 2. Value comes out of fraction. Why? There are 4 sulfurs, and all the sulfur don't have the same oxidation state. The average value is, the structure is this one. You can remove O, you can remove O, you can remove OH, but you will not remove S because they are same element. So -2, -2, -1. So opposite charge is +5. In this case also +5. This sulfur also carries +5. -2, -2, -1. So -5, if you remove 0, -5, 0, -5, the value comes to +5. The oxidation state of sulfur is +5. But in this case, the oxidation state is 0, because on this side is sulfur, on this side is sulfur. Similarly. So this is about the covalent case compounds. What about the ionic compounds? or binder compounds, I will say. Fe3O4, we get the value plus 8 by 3 by normal method, which is in fraction. Actually, this is binder compound. It is a mixture of Fu and Fu2O3. There are 3 iron and 2 iron have same oxidation state, but one of the iron has a different oxidation state. In this, the oxidation state is +2, but in this case, the oxidation is +3. And the average comes out to +8 by 3. On the other hand, in case of Pb3O4, again the answer is +8 by 3 because it is binary compound. Means all the Pb have not same oxidation state. Different oxidation. So 2 PbO, but they are in 2:1 ratio. Here is 1:1 ratio. Here 2:1 ratio. So in this case the lead has +2 oxidation state, in this case +4 oxidation state, and total +4 and +2 into 2 +4 +8, and it is distributed of 3 Pb elements, and hence the average value comes out with +8 by 3. In this way, I discussed the very important questions related to this chapter. Count for the fallacy, condition under which acts an oxidant and reduction, and I have also rationalized the oxidation state. Rationalize means I have to find out the oxidation state of each and every element by removing another element. Next time I will discuss how you will find out when the oxidations take place, when the oxidation reduction takes place in the chemical processes, and for the time being try to solve another questions in the NCERT text questions, and like this video.